Hello, everybody. What happened to the bakery when it burnt down? All right, here we go. Let's get to it. Uh, Here we go. Okay, so today we are talking about exponentials, new type of nonlinear relationship. We've been talking about parabolas, which are kind of like your smileys and your frownies. This is a completely different one. This one's called an exponential. So it describes something that increases at an increasing rate, which means it kind of gets faster and faster as it grows larger and larger. Okay, kind of like that line I drew. Okay, now what does it model? Hopefully your finance. Hopefully that's what happens with your money. It grows very, very large over time. It also models things like population, a lot of other things, but a lot of things will grow or, yeah, they'll grow financially or, sorry, exponentially. Okay, now, as per usual, we're going to start by completing a table of values. Now, I've done this first set for you. Now, the way that an exponential works, as you can see, is we're dealing with things that are to the power of some sort of x. Okay, so whenever you see x as the power of something, you know that your graph is going to look some sort of an exponential kind of graph. Now, hopefully this makes sense. 2 to the power of 0, or anything to the power of 0, is in fact 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. So you can see that I'm doubling every time this way. And then if I go this way, 2 to the power of -1, if you put in your calculator, it becomes half. Half of half is now a quarter. Half of a quarter is now an eighth. Half of an eighth is now 1/16. Okay, now at this point, what I want you guys to do is pause this video and see if you can fill in the remaining kind of blanks under here for -2 to the power of x, and 2 to the power of -x, and 3 to the power of x. Okay, so if you're in class right now, pause the video and try to figure those out yourself. Use your calculator if you must. See how you go. Okay, now hopefully you did that. If not, I prepared this earlier. So these should be your numbers. Please double check them and make sure you're kind of on the right track. Now, what we're going to do here is we're going to plot each of these onto our Cartesian plane. And so you can see here that when 0 becomes 1, now it's going to be very hard to tell, and this is deliberate. So 1 would be 2, 2 would be 4, 3 would be 9, 4 would be 16. So 4 is not even going to fit. It's going to be somewhere like up here. And then this one here is it's going to be half, quarter, and you can see it kind of gets closer and closer to that line, but it never really reaches 0. And so hopefully you can see that your exponential line looks something like this. Okay. Now, what happens if I make the whole thing negative? So you can see here for this second one, I'm going to use this red. You can see that it's essentially the same line, but now everything is on the negative side. So that means I'm going to have a very, very similar pattern. It's just this time I'm on the negative side, which means I'm on the bottom. 3 would be -9, 4 would be -16, which would be roughly there. And then these ones here get shorter and closer to the line. Let's see how we go. Close enough. Okay, so this one here, and I should probably label these as I go. This is y equals 2 to the minus x. And then the next one I have here is 2 to the power of minus x, and I'll do this one in green. Now, what's different about this is, I don't know if you noticed, it's all the numbers reversed. And so what you'll notice here is at -4, it actually becomes +16. It might fit on yours, it might not. 3 would be, -3 would be 9, -2 would be 4, -1 would be 2. And I've got 1, half, quarter. And this is where you try your best to, I know it's not going to be super accurate, but you kind of get the idea. Ugh, not my best one. should get closer and closer to that line. And this one here, I'm going to label as y equals to 2 to the minus x. And this last one with 3 to the x, if you draw this correctly, what you should notice is it should be steeper. Okay, so it still has the same shape, but it actually grows a little bit more. So 1 would be, instead of 2, it'll be 3. 2 would be straight to the 9. And then from there, it's already 27. So it's kind of essentially a lot quicker. So it's kind of still that same line, but it grows a lot faster, a lot quicker. Okay. Now I'll give you guys a chance to write that down. If you need to, pause the video. Those are your 3 different graphs. And again, please label them. That's y equals 3 to the x, and that first original blue one is the y equals 2 to the x. Okay. So we'll give you time to do that. Now, hopefully, as you've got that down, there are 4 types of exponential graphs. And I'll explain them to you. So when you do your general graphing later, which will be a lot easier and less intense than the one above, it should be nice and straightforward. So the first one here is, the first type is where you have everything positive, which means your a is positive and your x is positive. That means you're going to have your most regular type of exponential. Okay. Now, you can see it gets closer and closer to that 0 line, but it's never really going to touch it. So that's that. Now, you'll also have what happens if we have a negative power. So that means my base is positive, but my power is negative. It's just going to flip the other way. So instead of exponentially growing, we call that exponentially decaying. Okay, so it just kind of flips to the other side. Okay. For this one here, if I have a negative base, so I have a negative a, but it's to a positive power, it's going to flip this way. And for that last one, if I have everything negative, so I have a negative base and a negative power, it's going to look like this. Okay. So as you can see, those are your 4 main types of exponential graphs, and they will be either one of these combinations of positives and negatives. Okay. So get that down, write this down. It'll be helpful for you to refer to this as you do the exercise. Now, in general, and yes, I do want you to copy this down. So in general, you're going to have this formula here. Y is kind of, that's talking about the relationship. You're going to have some sort of base. You're going to have some sort of power of x. And so that k is talking about the number in front of the x. It could be positive or negative. That kind of gives you a bit of a hint. And then you may have this plus c afterwards, which we'll talk about what that does. So with this number at the front, what we noticed was with the base is the bigger the number, the steeper your exponential line becomes. Okay. So that's kind of that. And it also talks about whether it's positive. Yeah. Anyways, if it's above the x-axis or below the x-axis. So I should probably write that down. I'll say positive equals above x-axis. And negative means below x-axis. Okay, apologies. That k is just talking about the power of x. So if it's positive, we know that it kind of goes from left to right and it grows from left to right. If the number is negative, the number in front of the x is negative, we know that it starts to decay, or it starts to not grow, but we call it decline or decay. Okay. And this last one that we haven't talked about yet, it just means that plus c is a shift up or down, very similar to what we did with parabolas. So anything that is not connected to an x, if it's just like a +1 or a +2 or a -1 or a -2, that's just going to shift our whole graph up and down. And we talk about this thing called the asymptote. I'll show you what I mean by that. This asymptote is essentially where that line approaches, but it never reaches. So most of our graphs, it was just that straight flat line of your x-axis. Okay. Now, here's what your examples are going to look like. I'm going to run you through a couple, and this is what I'm expecting to see from your bookwork. Okay, so your questions will look like this. Sketch, and you've got these two graphs, y equals 4 to the x, and then I've got y equals 7 to the x, and if they want it on the same number line, we're going to do that. Now, for this one here, I don't need anything perfect. I just want to see that you know the relationship between these two. So both of these numbers are positive, so I know the first one, I'm just going to kind of draw, I know it's going to be that kind of shape. Oop. And I'm going to label it y equals 4 to the power of x. Now, if I have this thing called, oh, this y equals 7 to the power of x, it means that the line is actually going to be even steeper. So it's just going to grow a lot faster. And so it should look something like that. If you've drawn those two lines there, that is good enough for your sketch. It's showing that a bigger number means a steeper line. Okay. Hopefully that makes sense. This second question here, you've got a bunch of different things going on. You can see that this one here is you've got a positive base and a positive power. This one you have a positive base, negative power. And then this last one, you have a negative base, but a positive power. So we're going to have to figure out which one's which. Let's say, for example, that 4 to the power of x, that one's all positive. So I know by looking back at those notes, I know that the all positive kind of goes this way. Okay, now if it was 4 to the negative x, let's do this one in red. Now this one here just has a negative power, which means I know it's essentially still above the x-axis, but now it's going to go, instead of growing from left to right, it now grows from right to left. Okay, or decays from left to right, however you want to think about it. And this last one here is if I have a negative base but a positive power, kind of gives me the hint that I'm going to be going this way here. So y equals negative 4 to the x. And this one here, I forgot to label. It's just like that. Okay. And those would be your three graphs. All right, last one. This is the one where we haven't talked about the plus c yet. So let's talk about this first one. Y equals 2 to the power of x. Okay, I know that is my everything all positive, so I know that's going to be this kind of shape. Now, as you can see, this line is going to approach this. Think of this imaginary blue dotted line that I've just kind of dotted in. It gets closer and closer to that line, but it's never really going to reach it. So it gets very close, but it doesn't. Now, what's going to happen here is if I take 2x plus 1, sorry, let's label this as we go. If I now take this one, that 2x plus 1, what that does is it actually shifts my whole graph up 1 point. So now instead of cutting there, my whole graph is shifted up 1 point. So now that's the number 1. And then that means now my whole graph is shifted up by 1. And that would be your y equals to 2x plus 1. So that plus 1 or minus 1, it's going to shift your graph up or down. Now, as you can see, this last one here is a 2 to the x minus 2, which means that I'm going to shift down 2. So there's 1, there's 2. Shift it down 2. And now I know this graph is not going to touch that line. That's going to be my asymptote. But I know that the graph is still going to grow upwards and just going through that point there. Okay. Hopefully that makes some sort of sense. If you need to, pause the video, rewatch it, try to make sense of it again. You've got a couple questions up in Classroom. Good luck, all the best, and I'll see you guys later. Have a good weekend. See you guys later, and bye-bye. See ya.